Yes. Let's look here. So, what are hyperbolas?
Mm,
What are hyperbolas?
hyperbolic
Hyperbolas usually have a function 1 over
x
x, right?
is
That's the,
plus q
what is it?
plus q.
Okay, yes, plus q here, right? Plus
Mm.
q like this, right? So if I were to write everything, because I just wanted to show the basic one, without
Okay.
this. So let me make this. Um, oh, we um, so it would be something like this, right? And then on top here
Yes.
could be anything. It doesn't have to be one, it could be a different number. Let's call it A,
Okay.
right?
Mm.
So, so this is the general function for it. So
Yeah.
here, this one, uh,
Critical asymptote
vertical asymptote, and
is
then this one, what is it?
the horizontal asymptote.
So it's the horizontal asymptote when it's given as a negative
Mm,
here,
and
right? So P
is
is the horizontal
horizontal
asymptote
asymptote.
when it's a negative there, né?
Yes.
Mm, yeah. So how does this graph look like, right? To this
Mm.
graph, so a normal 1 over x, let's say y is equal to 1 over x. It goes something like this.
Yeah.
So it's much closer to the axis,
Yes.
like this, right?
Yeah.
It looks like that, right?
Mm.
Your horizontal asymptote here. So another way to solve for the horizontal asymptote, né? You just
Mhm.
take this and you equate it to 0 and solve for x.
Okay.
So you could take this x minus p is equal to 0,
Mm.
and then x is equal to p. That's your horizontal asymptote. Mm. That's the easier way where you don't have to think too much. Just take
Okay.
this, you equate it to 0, and then you solve for
Mm.
p.
Okay.
Right? Right?
Yeah.
Just stretching. So this is a better way to solve, né? So the horizontal
Yes.
asymptote there, it's gonna be x is equal to 0. Vertical asymptote, y is equal to 0.
Zero.
Why am I saying that? Because here, let me write it in blue. Here there's a plus 0, isn't it?
Yes.
And then so something like this, and then there's a plus 0 here for q,
Yeah.
right? So that's why the horizontal asymptote is 0, the vertical asymptote is also 0,
Zero.
right?
Yes.
Know that. So let's go through the effects of A. So A determines the shape as well,
Yes.
right? A
Mm.
tells us the shape. Now in this case, if A is positive,
Mhm.
if A is positive, the graph will lie on the first and third quadrant like this,
Mhm.
right? If we have a positive
Mhm.
A, right? First
Yes.
and third quadrant, right?
Yeah.
If A is negative, the graph will lie on the second
But and the
and
fourth.
fourth quadrant, just like this, right?
Mhm.
So if I said sketch something like this, right?
Yes.
You know the value, you know the value for A,
It's the negative
it's
one.
negative. So therefore, when you
Yes.
draw, your graph has to be something like so,
Yeah.
isn't it?
Yes.
Yes. So that's X, that's Y, like this, right?
Mhm.
Mhm. So I'm gonna go for a simple one now. For another one, let's say this is example two for hyperbolas. So now, um, so if I say draw y is equal to 2 over x, let me not say 2 because but it doesn't matter. You just know that it's positive, ne? Let me just say 2,
Yes.
it's fine. 2 plus 3 here, right?
Mhm.
Plus 4, for example.
Okay.
Right? This is the example that I want. And then they say determine the shape. That's what I'm asking for. I, I want you to determine the shape first.
Mhm.
Right? Second, I want you to determine the horizontal asymptote.
Okay.
So only one thing. Horizontal asymptote. Horizontal asymptote. Okay. The vertical. And then the vertical asymptote. And then, yes, let's start with this ones.
Okay.
Mhm. So what is the shape?
Okay. The shape will be on the first quadrant.
First and third quadrant.
First
Right?
and third quadrant.
So
Yes.
something like this, isn't it?
Yes.
And
Yes.
then um, the the horizontal asymptote.
The horizontal asymptote is -3.
So its x is equal to -3, right?
Yes.
Then the vertical asymptote,
The vertical asymptote will be 4.
y equal to 4, like this,
Oh,
right?
yes. Yeah.
And then they say draw it.
Okay.
So the first thing you need to take note, you need to draw the asymptotes first.
Okay.
Let's draw a graph. Say this is our graph, right? This is our
Mhm.
graph. And then, right, say this is it. So what are the asymptotes that we have? We have x is equal to -3. Right?
Yes.
So where is our, let's say the -3 is here. This is -3,
Okay.
right?
Yeah. Yes.
So the asymptote, we draw it, draw the line like this. That's it, right?
Yeah.
That's the asymptote. That's our asymptote. Y is equal, not y. X is equal to -3, right?
-3.
And then the other asymptote is y is
It's
equal to 4.
2, 4.
What is y equal to 4? So this is 4 here.
Okay.
Right? You see, now
Yes.
the shape goes first and third quadrant, right?
Mm-hmm.
We
Yes.
don't. So if let me draw it. I'm gonna draw it incorrectly now. I just want to show you something. So if you were to draw, you
Okay.
would draw it like this. If you didn't know what I was gonna say. Now,
Okay.
would this be correct if you were to draw it like
Mm,
this?
no,
Why?
because the lines are touching the asymptote.
Because the lines are touching the asymptotes. That's correct, right? So
Yes.
what we
Yes.
want, we don't want to touch the asymptotes.
Yeah.
We don't want to touch the asymptotes. So let's do this. Let's remove these. Um, okay. Let me remove. Um, yeah, no. Just delete. So we want lines that are not going to touch the asymptote. We
Yes.
shouldn't. We should not be touching the asymptote. So our line, the shape now, that shape is not only of saying the as the quadrants for the x and y axis. No, that one
Mm-hmm.
is talking about the asymptotes. When we have asymptotes, our line is
Yes.
gonna go like this,
Yeah.
right? Then it's gonna
Yes.
go like this, right? This is the
Yes.
correct way to draw them,
Yeah.
right? That is the correct way to draw them, Mali.
Yes.
So, so you draw them like this, and then here, so they would they might ask, say, oh, how do we calculate, or what is the value here? What is a here? What is the
Mm,
coordinates here? What is the y-intercept? What is the x-intercept? That's the question.
okay.
So to calculate the x and y-intercepts, you just put in y is equal to 0, and then you put
Mhm.
in, you solve, and then you put x is equal to 0, right? Depending on what is being asked.
Okay.
So let's just want to copy this, then uh, okay. So let's do this. Let's put it here, and then let's do another one. Okay.
Mhm.
So to find the y-intercept, we want the y value, right? So we're
Yes.
gonna put x is equal to 0.
Mhm.
Then it's gonna be y is equal to 2 over 0 plus 3, isn't it?
Yes.
Plus 4, yeah. So what is the y
Yes.
value?
Y value will be 14/3
14 over 3 or
or
if
4,6.
4,6, right? That's the
Yes.
y value. Where?
Yeah.
Here,
On A
right? 4 comma
is
6 here,
6.
right? 4,6 there, right? And then
Mhm.
to find b, where is the x-intercept? What do we do? So we're looking for the x-intercept.
Yes.
X-intercept. So we're gonna set y is equal to 0.
Yes.
Then that equation is gonna be 0 is equal to 2 x plus 3 plus 4, right?
Yes.
Take the 4 to the other side, negative 4.
Yes.
Sorry, not 2, it's x. Mhm. Um, And then to find you multiply by x plus 3 just to get rid of
yes,
it both sides,
yeah,
right?
mm-hmm,
Multiply by x plus 3 both sides, and then it's negative 4x minus 12 2,
yes,
just like this. And then you take the number, take this that side,
by that side
and negative
should be positive
4x, that's gonna be 10.
14, wait,
Oh, sorry, yes, it's gonna be positive that
14,
side.
yeah,
15, right?
yes,
Why is my back the back?
18,
So 14,
yes,
right? So we're gonna divide by negative 4.
which will be negative 7 over 2,
So x will be
so
negative 7
negative
over 2,
7
or,
is
in decimal,
negative 3, comma 5.
negative 3 comma 5,
Yeah,
right? So these b would be negative 3 comma
comma
5,
5.
right?
Mm-hmm.
That point there, right? So coordinates
Yes,
for b is negative 3
3,
comma
comma
5
5,
and then 0 there,
0,
right? And then for a, x is
is
0, y is 4 comma
4, comma 6.
4 comma 6. So this is how you tackle questions like that,
Okay.
right?
Mm-hmm.
That is how you tackle them. Let's look at, right? I think for now um, yeah, for now I think let's stop here. Um,
Okay.
yeah, let's stop here. I just wanted to go through a bit of the um, the curve, the hyperbola with you, right?
Okay.
And
Yeah.
then so so and then let's see. Um, mhm. So I just want to show you the cubic function, just something in general. I'm not
Okay.
gonna go into detail, just right, just gonna show you what it means, what some of it means. Right, you're gonna say y is equal to a x to the power of 3 plus bx squared plus c x plus d, like this, right?
Yes.
For an a value that is positive, if a is positive,
Yes.
if a is positive, the shape of it looks like this. It goes up,
Okay.
right? It's going up there, right?
Mhm.
If A is negative, if A is negative,
Yeah.
the graph is going down like this.
Okay.
Can you see?
Yeah.
Huh? So let's just say we have, oh, and then we have two turning points, right? We have a
Yes.
turning point here and then a turning point there, right?
Yes.
We have two turning points. So here we're going to have a turning point here, and then here we're going to have a turning point there, right? And
Mm.
then this one here in the middle, you would have a point of inflection. So
Okay.
the one in the middle is the what we call
Point
point
inflation.
of inflection. Inflection, like this, right? You
Okay.
see, let's say we are given y is equal to um, let's just say x to the power of 3 plus 2x squared plus let's just say 3x minus 1 like this. Hmm?
Mm.
How do you find the turning points? So to find the,
Okay.
yeah, go on.
By using both the formulas
Mm-mm.
and using the points
No,
that were given.
no. So the formulas are for quadratic. This is not quadratic.
Oh,
This is cubic. It's to the power of 3. It's not to the power of 2. So
we have to derivate first.
yes, you have to, right,
Yeah,
differentiate first. And
yes,
then when you
yes,
differentiate, you equate everything to 0.
zero is
So here you're gonna get, let's say you're gonna get 3x. Um, let's say this
it.
one was let's say this one was negative here, right? This one was negative, right? Like that. 3x squared plus 4x, right? Minus
Mm,
3, right?
yes,
Then you do what you do, you equate this to 0, it becomes 0,
yeah,
right? Then you're gonna use your Pythag your quadratic formula, right? You're gonna have,
yeah.
so you would use quadratic here, and then you say x is equal to, you get the first value, and
Mm,
then you're gonna find the second value as well. These are the values at the turning point.
okay,
The values you get, can you solve for this using quadratic formula?
okay. Okay, the first value will be 0.53.
Mhm. Second one,
The second one will be negative 1.86.
negative 1,86.
Yes.
Okay. So these are the two values for the turning points for x.
Okay.
So to find the y value, you then go like this. Back into the original equation, you're going to put the values that you found,
Oh,
right?
okay.
So you're going to go 0,53. I'm just going to show you, there's no need to calculate, right?
Okay.
So
Mm,
just So 2x squared minus 3x. Okay.
Mm-hmm.
0.53 squared minus 2x 0.53 minus 1, just like that. Then you'd find the
Okay.
y value for the for this one, for the turning point
Mm-hmm.
for this one, and then you
Mm-hmm.
do the same thing for negative 1.8.
Okay. Let me check.
Huh? No, I'm not saying calculate. I'm just saying this is how you do it,
Oh, okay.
right?
Yeah.
So with that, you're gonna say your turning point there. Um, you're gonna say the turning point at first. It's 0.7553, and then the y value, right? And then the
Mm-hmm.
next turning point is what? It's negative 1.86,
It's
and then put the y value for it,
okay.
right?
Yeah.
And then and then to find the point of inflection, what you do is you differentiate again.
Okay.
Differentiate again. Right? So what do I mean by again? I mean, so mm, so you, you differentiated once and you got
Yes.
what? You got this.
Yes. Okay.
Right? Okay, you got this,
Mm-hmm.
right? Now
Yeah.
what you do is you differentiate again. You take this and you differentiate again, right?
Mm.
So something is wrong with this computer today. So slow. So you differentiate again, you're gonna get what? 6x
Yes.
plus 4, right? This is
Yeah.
the you're differentiating again, right?
Mm-hmm.
Sorry, it's not like that. You're differentiating again, right?
Okay. Yeah.
When you differentiate again, then again you equate it to 0, right?
Mm.
Then you solve for x. You're gonna find
Okay.
that x is equal to negative 2 over 3.
Yes.
That's how you find that point of inflection for x. To find the y value, you take the origin, you put this thing back into the original equation. I think it was what?
Six. Mm.
No, it was not. There was no 3. It was gonna be negative 2, negative 2 over 3, the power of
Mm.
3 minus, I don't yeah, something like this, right?
Oh, there was two.
Right, this is 3, ne?
Yes. Minus one. Mm-mm. No. There it was 2x minus, it was 2x squared minus 2x. Yeah, this one.
2x squared minus 3x.
Yeah,
Right. So here I made a mistake as well.
yes.
So it has to be 3.
Mm.
Mm, That's 2. Then you
Yes.
find the y value for it. Then that's
Okay.
your turning point. That's your point of inflection, sorry. So that's
Okay.
your PI. right?
Mm-hmm.
Right, negative 2 over 3, and then that, right?
Yes.
So those are the steps. To find the turning points, you differentiate once. To find
Mm.
the point of inflection, you differentiate twice,
Okay.
right? So that's it.
Yes.
And the shape tells you everything you need to know, right?
Okay. Yeah.
Okay, yeah. Thank you. I just wanna rest for now, eh?
Okay. Thank you.
All right, cool.
Bye.
Bye.